Okay, ladies and gentlemen, welcome back. This is the second part of the video on vectors. So in the first part, we learned that a vector is different from a scalar because a vector requires a magnitude and a direction in order to be completely specified, whereas a scalar simply requires a magnitude or a number. We learned that vectors have two components to their motion. Vectors can often have two components, an x and a y component, and that we have to use the Pythagorean theorem to resolve perpendicular vectors. We also learned that we can add collinear vectors tip to tail, and it's just super easy. It doesn't require any trigonometry at all or any kind of Pythagorean theorem. In this part of the video, we're going to look at what to do to get the angles. And we paid attention to how to get the magnitudes of vectors that were at right angles. Now we're going to try to determine the angles. So we have to use sine, cosine, and tangent, or those trigonometric functions that you've learned to grow to love. All right, so vector directions are given in two different ways, either using a coordinate system or a cardinal directional system. So it kind of depends on the setup of the problem. A coordinate system is a vector given by an angle relative to the positive x-axis. This is kind of unusual. We don't see that all that often. So in this using the coordinate system, it means that all angles are measured from right here. So this would be a 270-degree angle. However, so a positive 270-degree angle would be there. A negative 270-degree angle would be here. So we always look at it as being counterclockwise for the positive direction. Again, those are the quadrant labels, 1, 2, 3, and 4. That's something I hope is fairly intuitive for you, that this would be 0 degrees, 90, 180, and 270. And once we make it all the way around, that would be 360 degrees. Okay, so let's look at this one. This is a displacement for a 400-meter trip at 220 degrees. So just drawing that vector. So you want a vector that's represented as 400 meters in length, and it's at an angle of 220 degrees. So if we start here, this is 90, this is 180, this is 270, so it's going to be right inside here somewhere, okay? So if you drew it in there, and then based on what you'd already established as a frame of reference, the length of the vector would determine that it was 400 meters. This doesn't show you any kind of a scale to indicate the length of this vector, but this length should be based on a scale that's provided. Okay. And this angle right here, often this will be described from this angle right here rather than all the way from here. So this is 180 to 220, so this is a 40-degree angle below the negative x-axis. So lots of different ways to show the same place. Okay, so now here's another one. A woman sails her boat with a net displacement of 3 kilometers at 112 degrees. Draw the resultant vector. Okay, so, shucks. So you're just going to have to compare that with one another. If you have an x and a y, then if the 90 degrees is here, then you're going to have a vector that's over past 90 a little bit, but not too far. So like about 11 o'clock, if we were looking at it on a clock. Okay, here's another one, but this is using the cardinal system, which means north, south, east, west. This is not terribly uncommon. So this would be 25 degrees south of east. This one, 25 degrees east of south. That's a little bit awkward. Sometimes you'll see these as being like 25 degrees below the horizontal or 25 degrees above the horizontal. It's a little bit less common to see it as south of east and east of south, but you can see it that way sometimes, so you have to know how to interpret that. Okay, let's think about this one. We have a plane that is maybe at 400 kilometers per hour and it's 30 degrees north of west. Then how's that going to look? So sorry this isn't on here, but 30 degrees north of west. Well, if this is, so north, south, and it's going to be east, west. So 30 degrees north of west is going to be right over here. It's going to be in the first quadrant. Okay, the next thing that we'll do is think about how to calculate the angle of a resultant vector using sine, cosine, or tangent. So this is just using your basic trigonometry. So if we have this set of sides specified, then this means this is the angle, the target angle, because this is the opposite side, this is the adjacent side, and the hypotenuse is always the long side opposite the right angle. So there's my angle, my target angle, opposite, adjacent side, hypotenuse. If you remember, tangent is opposite over adjacent, sine is, tangent is opposite over adjacent, correct? Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Okay, let's look at this one. Plane leaves Chicago flying due east at 500 miles an hour. The pilot forgot to check the weather and doesn't know that the wind is blowing south at 100 miles per hour. What direction will the plane travel? We're going to assume that the pilot doesn't do anything to correct this issue. So if this is Chicago, then this is his this is the flight vector, the velocity vector for the plane. However, there's a crosswind pushing this plane this direction. So if this plane continues at this heading and at this speed, then the wind is going to push it off course this far. And if we calculate that, we can just use Pythagorean theorem to find the magnitude. We'll take the square root of the square of the sum of this and this. And then to find the angle, for this angle, I would use the values that I was given. I would never use a value I calculate, so I wouldn't use the hypotenuse. So I would look at this and I would use opposite over adjacent, so I'd use a tangent function here. So I'd use 100, I'd use inverse tangent of 100 over 500 to find the angle theta. So opposite over adjacent, so inverse tangent of opposite over adjacent means that you'll have inverse tangent of 100 over 500. The negative sign isn't necessary there. You can keep track of where it goes without including the positive and negative sign. So this just means that it's going to be 11 degrees in the direction, in this direction. You know from the picture what direction it's going to be. Again, we didn't find the magnitude here, but we know that it's going to be 11 degrees off its course. Okay, this one, a car travels at a velocity of 10 meters per second east and then travels at a velocity of 19 meters per second north. What direction is the car's resultant velocity? Okay, so this is one where we have just two legs of a trip. So, so on this one, we have a car that moves due east at 10 meters per second and then due north at 19 meters per second. We're going to assume that it travels, this is a little bit wonky. We're going to leave it as it is. But just assume that it's, you can just add these, do vector addition with these and determine the resultant velocity. So squaring this term and adding it to the square of that term and the square root of all that will give the magnitude. And then you have a 10 meters east and a 19.6 meters north. So that means if you use the tangent function, it's going to be the inverse tangent of 19.6 over 10 to give you the angle. So see how you do on that one. Okay. So now you need to do the vector worksheet. So there's a homework sheet that you can work on now. So good luck with that.